In the previous video, we looked at a couple of examples of factorization. Unfortunately, it's not always easy to factorize, and that you have nice expressions with integers. Sometimes it's more difficult, and in cases like that, we have a formula to help us. It's called the quadratic formula. And there are basically two steps when you use the quadratic formula. If you want to find the solution of an equality ax squared plus bx plus c is equal to 0, then you can use the two-step procedure. First of all, you calculate the discriminant, which we call d, and d is equal to b squared minus 4ac. Secondly, you use the discriminant to substitute into the formula for the roots, and there are two formulas for two possible roots, because remember, we're looking at a quadratic formula, so that's why there's two roots. And again, you can also write the formula like this, but it's usually a little bit easier to just calculate your d first and then substitute it in. Otherwise it can become quite complicated. Let's try an example. First we'll start off using our quadratic formula. So we're going to calculate d. d is equal to b squared minus 4ac. In this case, b is minus 3. So it's minus 3 squared minus 4 times a, which is 1, times c, which is minus 4, which is equal to minus 3 squared is 9, minus 4 times minus 4 is plus 16, which is 25. x1 is equal to minus b plus the square root of d over 2a, minus b minus minus 3, which is 3, plus the square root of 25 divided by 2a, which is 2 times 1, which is 2. And that's equal to 3 plus 5 over 2, which is equal to 8 over 2, which is equal to 4. Then we use the formula for our second root. If you look at the formulas, it's the same as the first one, except instead of plus the square root of d, it's minus the square root of d. So we can rewrite it as 3 minus the square root of 25 divided by 2a, which in this case is 2, equals 3 minus 5 over 2, which is equal to minus 2 over 2, which is minus 1. So we found our roots. We could also do this by factorization. If these are our roots, then we say, okay, x minus 4, x minus minus 1 is equal to 0. In other words, x minus 4, x plus 1 is equal to 0. And we can check it because we have our rule. We say minus 4 times by 1 is minus 4, and minus 4 plus 1 is minus 3. So that's another way of working out our roots. Let's look at a second example. This expression is 2x squared minus 4x is equal to 0. First of all, we find d. d is equal to b squared minus 4ac. So in this case, b squared is minus 4 squared times by 4 times a, which is 2, times c, which is 0. So this part is 0, and minus 4 squared is 16. Our first root, x1, is equal to minus b, so minus minus 4, plus the square root of 16, divided by 2a, so 2 times 2, which is equal to minus minus 4 is 4, square root of 16 is 4, so 4 plus 4 is 8, divided by 2 times 2 is 4, equals to 2. x2 is equal to minus b, so minus minus 4, minus the square root of d, divided by 2a, which is 2 times 2. So that's equal to 4 minus the square root of 16 is 4. So 4 minus 4 is 0, divided by 2 times 2 is 4. And 0 over anything is 0. So our roots are 2 and 0. And if we check it by factorizing, then we end up with x minus 0, x minus 2 is equal to 0. In other words, x minus 2 is equal to 0. And if you take a look up here, you can see this is correct. Doesn't look like it in the first instance, but you can divide this by 2. So you have x squared minus 2x is equal to 0, and that looks a lot like this.